Hello Pre-Calc Excel students, and welcome to lesson 6.1 on the law of sines. Now, some of you may have learned about the law of sines in geometry, so this may be review for you, but I am going to treat it as though you're learning it for the first time. So the law of sines, what it allows us to do is solve triangles that are oblique, meaning they are not right triangles. So if you remember from geometry, you had methods of proving triangles congruent, right? There's AAS, ASA, SSS, and SAS. We determine which law we can use, because there's also the law of cosines, based on the given information. So for AAS, remember that means two angles in a non-included side. And ASA is two angles and an included side. So if we have either of those cases, we can use the law of sines to solve that triangle, meaning finding all missing parts. SSS is another case. If you remember, this does not prove congruency, and you're going to see why in this section. Okay, so you may remember that from geometry, but SSA is not a method for proving congruency. And again, you will discover why in this section. So here's what the law looks like. It's a set of ratios. The sine of A over side A is equal to the sine of B over side B, which is equal to the sine of C over side C. And then let me show you where it comes from. So I drew in a perpendicular. We'll call that H. And if I use this triangle on the left, I'm going to set up the sine of B, which is the side opposite over hypotenuse, so it's H over C. I'm going to use the triangle on the right to set up the sine of C, which is equal to H over B. Now I'm going to take each of these equations and solve for H. So I get C sine B and B sine C. And remember, if two things equal the same thing, then they equal each other. So I can set C sine B equal to B sine C. Do a little bit of division, and I get the sine of B over side B is equal to the sine of C over side C. Now, I could draw in another height and set this up all over again and show that the sine of B over B is equal to the sine of A over A, and the sine of A over A is equal to the sine of C over C. Okay, so when we use the law of sines, this is what our proportion will look like. So basically what you need three things. And two of those three things need to be an angle and a side opposite. As long as you have that, you can use the law of sines. So let's try an example. This one, we're going to write our answers in simplest radical form because we've got special angles that we can work with. So I've got that combination of angle A and side A. So I'm going to write the sine of 30. That's a degree mark. Over, that's the symbol for feet, but I'm going to leave that out of my proportion. And then I have angle B, that's my third part. So the sine of 45 over side B. So the first part I'm solving for is side B. The sine of 30 is a half. That's over 32. The sine of 45 is root 2 over 2. If I cross multiply to solve my proportion, I get 1/2 B is equal to 16 root 2. And then multiplying both sides by 2, I get B is equal to 32 root 2. Okay, let's see. Angle C. Angle C I can just get from subtracting these angles from 180, so that's 105. So there's two of my three parts. Make sure everything is labeled, right? We use capitals for angles, lowercase for sides. And I can put that foot mark back in with my final answer. So now I'm going to use, since this works out nicely, I'm going to use angle A again. So the sine of 30 over 32 is equal to the sine of 105 over side C. So again, that's 1/2 over 32. Let's see. So what do I want to do with that? I'm just going to, I think I'll just leave that. I'll remember this is 32 over 1. So when I flip, I'm going to just make this 1 over 64 for now. And that's times C. Let me get the C out of the way. So I'll multiply. I'm running out of space here, so I'm going to condense this. Is equal to the sine of 105, and we can do this by hand now, right? Using our sign of a sum. That's equal to the sine of 60 plus 45. Okay, so when I expand that, I get the sine of 60, cosine 45. The symbol stays the same, sine 45, cosine 60. The sine of 60, that's root 3 over 2. The cosine of 45, root 2 over 2, sine of root 40, or sine of 45 is root 2 over 2. That should be a plus symbol. And then the cosine of 60 is 1/2. And that's, my pen is going a little crazy here. Sorry, that's a time symbol. Okay, so the sine of 105 is equal to the root of 6 over 4 plus the root of 2 over 4. And now that's what C over 64 is equal to. So I'm going to multiply this by 64 to solve for C. So the 4's reduce out with the 64, and that becomes 16. So let's see if our answers match up here. Okay, so we've got angle C is 105, B is 32 root 2 feet, and 16 times root 6 plus root 2, and that's in feet. Okay, now this is an exception. More often than not, we're going to be working with decimals. So make sure you have your calculator ready. Make sure your mode is in degrees. And here we go. So we have a word problem. A tree grew 6 degrees from the vertical toward the east. So let me sketch that in. I'm just going to draw my tree as a vertical line. I'm not going to get real fancy here. It grew 6 degrees, which I'm going to over exaggerate just so I can fit my 6 in there. So that's my 6-degree angle. And that looks like a blob there. Let's try again. Okay, leaning toward the east, right? That's to the right. So at a point 30 meters from the tree, in the direction that it's leaning, the angle of elevation to the top of the tree is 22.5 degrees. So I'm going to go out a distance of 30 meters. Okay, so there's my 30 meters. And then from that point, the angle of elevation to the top of the tree is the 22.5 degrees. And we are asked to figure out the height of the tree. Now, in this case, the height, think of it more as the length of the tree, right? It's not the distance that the top is off the ground, it's the actual length of the tree. So we are finding, we've got this triangle, right? It's not a right triangle, so we're going to have to use the law of sines here to figure out, I'll label this H for height of the tree. So let's see what we've got here. We've got one angle. We're using two sides. We need another angle. Right, from the 6 degrees, remember this was a vertical, so we have a right angle here, and taking that 6 degrees away from 90 makes this angle 84. Now remember what I said, we need the combination of angle and side opposite. So we've got that here, right? That's what we're solving for. So I can set up the sine of 22.5 over h. And actually, you know, you can set up your proportion any way you want. I like keeping what I'm solving for in the numerator. So let's try it that way. So remember, from your rules or properties of proportions, you can flip, right? You can flip this around. I could do 32 over sine 30 equals b over sine 45, and that's still a valid proportion. Oh, I didn't put my angle there. Okay, now for my other ratio, I need an angle and I need a side opposite. And here, let's see, I've got this 84-degree angle, I don't know this side. I've got this side of 30 meters, but I don't have this angle. But, of course, I can get it. Right, so if we take 180, the sum of any triangle, and subtract the 84, subtract the 22.5, we end up with 73.5 degrees. So the other side of my proportion, I'm going to use the 30 meters and take the sine of 73.5. So go ahead and cross multiply. Keep in mind, here's another little tip. When you cross multiply here, oh, what am I doing? When you cross multiply here, this is 30 sine 22.5. I don't know if you knew this already, but you do not need a time symbol here on your calculator. You can enter it just like this. The calculator will know that you're multiplying. But again, make sure you're in degree mode. And then divide by the sine of 73.5. So go ahead and calculate that. That will give you the height of the tree. And hopefully you came out with 11.97. And that's in meters. Okay, now this is an example where we're going to talk about side-side angle, which remember is not a way to prove triangles congruent, and now you're going to learn why. If I have two sides, right, 4.1 and 3.2 for lengths, and I have this angle of 27 degrees, and again, this is a non-included angle, I could construct this triangle, right, where E is the acute angle 27 degrees, F is an acute angle, that is not a congruency symbol. Let me get rid of that, that's confusing, I'm not sure why that's there. And G looks obtuse, right? I can use my law of sines to solve. First thing I'm going to solve for is side G. So I would set up, whoops, I'm going to set up the sine of, let's see, I'm sorry, did I say the first thing? I'm not sorry, I'm solving for side G. I'm solving for angle F. So I'm going to set up the sine of 27 over 3.2 is equal to the sine of F over 4.1. And I'm going to cross multiply 4.1 sine 27 divide by 3.2, and that will give you what the sine of f is equal to. So I'm getting that the sine of f, I'll put it up here, is equal to 0.58167. I'm just going to do 17. Now on my calculator, I'm not rounding. I'm going to take the sine inverse of that value. I'm going to use my answer button, right? That ANS button. Very useful. It's above your negative symbol at the bottom of your calculator if you're using a graphing calculator. If you have a scientific calculator, sometimes it has its own key. So I'm going to do sine inverse of my answer, and I end up with angle F equaling 35.57 degrees. Okay, with that being the case, I could then subtract these from 180 and get angle G, and then set up another proportion and solve for side G. So again, angle F is acute and angle G is obtuse. I could set up another proportion, solve for side G. Now, here's the thing. Right here at this step, when I took the sine inverse of this value and said that F is 35.57 degrees, there's actually another possibility. I'm going to call this one F prime. F prime, if you remember from our unit circle, the sine of an angle is the same as the sine of its supplement. So for instance, if we think about 30 degrees, right, the sine of 30 degrees is a half. The sine of 150 is also a half. And that's true of any angle you think of. If you look at the sine of its supplement, you're going to get the same sine function value. So F prime is going to be the supplement of F. So if I do 180 minus F, so 180 minus 35.5, I'm just going to use my answer button. I still have that value, so I'm going to 180 minus my answer gives me 144.43 degrees. Now, if I go back to the original given angle E, and I add 27 onto this, I am still below 180. With that being the case, I actually have two different triangles that I can draw here with this given information. And if you look at the next slide, you'll see what that triangle looks like. So here again is angle E, that's 27, side EG, which is still 4.1, and GF is still 3.2. But if I look at the obtuse angle F, I get an entirely different triangle. And this is why you cannot use side-side angle to prove a triangle, to prove that two triangles are congruent. Because when you have this scenario of two sides in a non-included angle, and you have the same thing in another triangle, it could be this triangle and it could be this triangle, which are obviously not congruent. So we call this the ambiguous case, meaning there's different possibilities. Side-side angle is the ambiguous case. And if you continue solving, actually pause the video, go ahead and use this angle F, or what I called F prime, 144.43 degrees, and solve for the rest of this triangle. Right? Get the new angle G, which is obviously going to be acute, and then find side G. When you're done, come back and we'll compare answers. Okay, so let's see how you did. So using the obtuse angle F, or F prime, G prime becomes 57 degrees, which remember in the other triangle, G was the obtuse angle, right, 117.43, and side G is 1.05. We didn't calculate side G in this other triangle, but you could. You just set up a proportion and you could solve for it. So again, given SSA, two sides in a non-included angle, there could be two possible triangles. Not always, but it's a possibility. Okay, so here's extra examples of the ambiguous case. So again, we've got two sides and a non-included angle, right? C would be the angle included between sides A and B. So set up a proportion. I want you to try examples 2 and 3. Set up proportions, solve for the missing parts, and then when you're done, pause the video while you're doing that, come back when you're done, and we'll compare solutions. Okay, let's see how you did. So for the first triangle, actually I'm just going to write this out real quick. So I'm solving for angle B. So when I do 14, if you were puzzled on this one, let's see what happens here. So I'm doing 14 sine 60 and I'm dividing by 4. I get that the sine of B is equal to 3.03. And it goes on and on. When you took the sine inverse of this, what happened? Did your calculator say error? Or maybe you didn't even take the sine inverse because you knew what was going to happen here. Right? Why are we getting error messages? Why is there something strange about this one? Remember, the sine function values, I can't have a sine of B equaling a 3 point something. I can't, or a 2 point something, or even a 1 point something. The sine of B has to be less than 1. So that's why, in this case, there is no triangle. So there's your 3 possibilities. For the ambiguous case, it's possible there's only one triangle. And we'll look at that. There's possible that there's 2 triangles. And it's possible that there's no triangle. And this is the case where it's the least amount of work, because when you see the sine of B equaling something greater than 1, you are done. Nothing else to do but say there is no possible triangle with this given information. And you could try to set up a drawing, right? If you have a compass and a protractor, you could measure the angle, try setting up the lengths, and you'll see that it's not going to work. You could not construct the third side to make it a triangle. Okay, example 3. Let's see how you did with this one. Okay, hopefully you got 2 triangles. We're going to call it case 1 and case 2. You can use subscripts, you can use the primes. I kind of like using the primes myself. But you want to do something so that it's clear to your teacher that you have the 2 different cases and the labeling is clear for each case. So for the first case, when I solve for angle B, I get 70.4. Right there. And I only have to do this when it's SSA. Okay, not the other cases. For SSA, we have to look at the supplement. The supplement of 70.4 is 109.6, which when added to the original given angle, it's still small enough that I have room for a third angle. And that third angle in this case will be 12.4 degrees. So if you didn't catch on to this second case, pause the video again and go back and set that up. Okay, example 4. Go ahead and try this one. Pause the video. This is again ambiguous. So see what happens. Again, your possibilities are that you'll have 1 triangle, you'll have no triangle, or maybe you have 2 triangles. Come back when you're done. Okay, for this one, there's only 1 triangle. The first angle I solve for is angle B. That ends up equaling 12.39. when I look at the supplement of B, the supplement of B is 180 minus 12.39. Hopefully you checked for that. So we'd say B prime is equal to 167.61. If I take the original angle A and I add on to this, I am over 180, right? That's greater than 180 right there. I can't have more than 180 degrees in a triangle. There's no second triangle. So that's how you can tell. Okay, if you look in the book, they do give you a chart how you can compare lengths, and it's to me it's a lot of memorizing. I don't do that. When I have the case of SSA, remember it's only SSA. If you go back to the original cases, AAS and ASA, you don't have that worry. It's only this guy, right, where we got to worry about the different possibilities. So when I have that case, I just remember that I have to think about the supplement. And if the supplement is small enough, like this case, that when added to the original angle, I still have room for a third angle, I've got two triangles. If the supplement is too large when added with the given angle, then I don't have two triangles, I only have the one triangle. And hopefully you got the rest of these parts in your solving process. If you didn't get any of these solutions, please ask in class and we'll go through it. Okay, on to the area. There's an area formula that can be derived from the law of sines. So again, I drew in a perpendicular. This is the height of the triangle. We all know that the area of a triangle is 1/2 base times height. In this case, the base is A, so it's 1/2 A. And I'm going to come up with an expression for H. Let's see, I think I will use the sine of B. So the sine of B is equal to H over C, which means C sine B is equal to H. So I'm going to substitute that in. So it's C sine B. Whoops, capital B. And there's my new area formula. So look at what we have here. We have two sides, and B is the included angle. So if I have that combination of side angle side, I can use this formula to calculate the area of the triangle. So here we have a triangular lot with sides of 24 yards and 54 feet that form an 80-degree angle. So we don't really need a drawing, but when it says if they form an angle, that means that these sides are the sides that include that angle. So it means the angle is included. Now look at this. Here's the tricky thing here. I have different dimensions, right? I can't multiply yards times feet, so we've got to convert one of them. Either of these actually could be easily converted. I forget what my answer is in, but usually we convert the larger of the dimensions. That's usually easiest. There's 3 feet in the yard, right? So 24 times 3 gives me 72 feet. So for area, I'm doing 1/2 72 times 54 times the sine of 80 degrees. And when we calculate that, oh, I picked the wrong one. Oh well, that's okay. If you converted the feet to yards, then we're dividing by 3, so this would be 18 yards. That's one way to do it. Or you could convert, let's see, if I have 36 times 54 sine of 80. Okay, I got 1,382.67, and this is in feet squared. Now, do you remember how to convert? Just a little tip. Right? It's not the same as the straight dimension. Right? To convert feet to yards, we divided by 3. Right? I don't want to divide by 3. This is square units, right? So if I have square feet, I have to divide by 3 squared. So if we take that number and divide by 9, then, hang on a second. What did I do here? Oh, shoot. This original number is not accurate here. Hang on a second. I hit a wrong digit in my calculator. Just noticed. So this is why it's good to check things. Okay, let's back up a minute. Okay, so that's actually 1,914.46 or 47. I'll round it up. Now divide by 9. And I get the 212.7 square yards. Okay, so if you need to convert, if you've already done the problem and you need to convert, just remember if you're squaring, if you have square units, you have to square that conversion factor. Okay, the bearings. The bearings are back. We're going to be using these to solve problems. So we have a child who swam from A to B in a direction of north 28 degrees east. Remember your north, south, east, west. Or never eat shredded wheat, or never eat soggy waffles, right? Whatever it takes to remember those directions. So northeast, that's off in this direction, right? Then the child changes direction, I guess, to come back to the shoreline and goes northwest. So let's start, I'm going to start down here. Let me get a solid line here. Make it a little thicker. Whoops, maybe some color. Okay, so let me do a little north, south, east, west thing here. So this is the starting point for the child. This is A. And then remember, for that bearing, we start north and we sweep to the east that many degrees. So 28 degrees, we'll say that's about there. It looks like I'm a little high. Let me bring this down. Whoop. That's a little better. Okay, so this is my 28 degree angle here. And now the child changes course. So I'm going to do another north, south, east, west. Let's bring that up. And now the child is going off from the north to the west. To get back to the shoreline, they're going due north of A. So this is B, and this will be our endpoint C. So let me just extend this vertical straight up, and that's point C. Okay, so we've got the 28 degree angle. We know this bearing is 58 out here. We know C is 800 meters due north of A, so that's 800. And we're asked, how many meters did the child swim? So we want this length, we'll call this side C, and we want this length, which is side A. So I need some more information here, I think, right? We've got this angle in the triangle. Remember, if I extend this, now I'm actually going to do a dash, but if I extend this horizontal, I get 2 right triangles. So if this is 28 degrees, this is the complement of it, right? So this would be 62. And then the same thing here. You can also use alternate interiors, right? This is 28, this is 28. Lots of different ways to look at it. This is 58. Then again, this is its complement. Right, so this angle here would be the complement of 58, which is 32. So that gives me an angle of 94 degrees. So now I know 2 angles of the triangle, which means I actually know all 3 angles of the triangle. That gives me enough, along with this side, to solve for sides C and A. So go ahead and do that. Find those side lengths, pause the video, add them up to get the total number of meters the child swam, and then come back when you're done. We'll compare our final answer here. Okay, let's see what we've got. Hopefully you got 1,056 meters. If you did not, then make sure you ask in class and we'll run through the rest of the problem. Okay, so that concludes lesson 6.1 on the law of sines. I hope you enjoyed it, and I will see you in class.